So example 3, write an equation in the xy plane. So we have a physics question. An elliptical gear can be used to generate variable output speeds. So we've got a question here with, this is after a 30-degree rotation, the equation for the rotated gear in the xy plane is given. Write an equation for the gear formed in the xy plane. So we're going to write the equation. So we need to find the equation in the xy plane. So x prime is equal to x cosine 30 degrees plus y sine 30 degrees. So our y of theta, so this is going to be y cosine 30 and minus x sine 30. So now we need to substitute in the values. So we're going to look at the values for cosine of 30. So this will be 3 over 2x, and we have a sine of 30, which is a half, so this is going to be a half y. And then for our y theta, substitute in, we'll have cosine of 30, so this is going to be 3 over 2y minus a half x. Now I could rewrite these over the same denominator, so we will have 3x plus y over 2, and then we'll have 3y minus x all over 2. Okay, right, so next step. We have our two equations, so we can substitute these into the original equation. So from the question, we have x prime squared plus 4y prime minus 40 equals 0. So our x prime, so this is going to be 3. So we'll use I'm going to use this that I've written here. So 3x plus y all over 2, and this is going to be squared. So our y, so our y value, root 3y minus x all over 2, and this is minus 40, so I'm going to take 40 to the other side for the moment. So we're going to look at multiplying this bracket, and because this is in the form of a plus b, so this is going to be a squared plus b squared, we're going to use, so root 3 squared is going to be 3x squared, so 3x squared, and then minus, so plus 2 times root 3 times 1, so that's going to be 2 root 3, and then it's multiplied by x and y, and then we've got our y squared, so plus y squared, and the denominator is 2 squared, so that's going to be over 4. Okay, looking at the second bracket, so this is also squared, so I should have squared here also. So let's have a look. So we have root 3 squared, so that's going to be 3. So 3y squared, and then it's a minus b, So this is going to be minus 2ab. So minus 2 root 3xy and minus x squared. So that's going to be plus x squared. And then this is all over 4. So we've got that equal to 40. Okay, so we need to simplify this. So 3x squared plus 2 root 3 xy plus y squared. And this is, we're going to multiply, so distribute, so 4 3s 12y squared. Then we have plus 4 minus 2, so that's going to be minus 8 root 3 multiplied by x and y. And then 4 times x, so plus 4x squared, and this is equal to 40. Now on the denominator we have 4, so let's write this like this, all over 4. And if we multiply everything by 4 on both sides, we can eliminate these terms. And now we can look at simplifying. So I'm just going to rewrite this 40 times 4. So this is going to become 160. We're going to look at simplifying. So we have, oops. So we have a 3x squared. We have that's a 12y. Right, try again. So we have a 3x squared and we have a 4x squared. So we can write those together. So that's 7x squared. And then we look at the xy's. So we have a 2 root 3xy and we have a minus 8 3xy. So a plus 2 minus 8 is going to be minus 6. So this is going to be minus 6 root 3xy. And then if we look at the next term, so we're looking at y squared. So we have a y squared and a y squared. So this is going to be plus 13y squared. And if we bring back from the other side, this is 160, so we'll have minus 160 equals 0. So we have our equation. And if we just check that. Okay, so using Desmos graphing calculator, we can put in the equation and you can see that we have a rotated ellipse. So we could also check using the discriminant. So from our equation, we've got a is equal to 7, b is equal to minus 6 root 3, and c is equal to 13. So b squared minus 4ac. So b squared is going to be minus 6 root 3 squared minus 4 multiplied by 7 by 13. So this is going to be minus 256, so this is going to be less than 0. So we know that when the discriminant is less than 0, we look at the other values, and if either b is not equal to 0 or a is not equal to c, then it is an ellipse.